The pole set, Mother Earth, the best ground there is, okay? So this first demonstration, simple demonstration to show you how animals impact our system. Now, we are inside of a building here, okay? So if you have never experienced this, this is gonna get your attention, and it has the potential to be loud inside of this building. You may wanna plug your ears. If you happen to have a hearing aid, you may wanna turn it down. Okay? We're hot. Ryan's gonna take Carl down. He's gonna ground him out. Boom. All right? How many times have you heard that loud bang outside of your home? Okay? Storms coming in from the west. You ever see the blue flashes at night in the sky? Okay. Inside of this throttle, all right, is normally a fuse link, okay? A fuse link in here, all right? That fuse is what we just blew, okay? Just like in your home. If you do something with a receptacle in your home that you're not supposed to do, what happens? Trip a breaker, okay? For us, we blew up a fuse inside of this throttle, okay? This fuse, few dollars. That transformer, few $1,000s, okay? We're protecting our devices with a fuse, just like we do inside of our homes. Next up, our little buddy out there. How many of you have seen our lovely little Sammy the squirrel, okay, running across the service wire coming into your home, driving down the road, okay? Sammy causes the most outages. Hey, thanks. Fuse. Wanted to show you, okay? This is our fuse inside of that throttle, okay? Inside of here is the fuse link, and when that occurs, okay, we blow inside of here. Sammy crawls out across that wire, grabs a walnut off the ground, climbs up that pole, gets up on top of that transformer, okay? Spring and fall, all right, it's cooler, transformer is warm. They get up on the transformer. You'll notice on this transformer now, on the top there, we have two, what we call bushings, okay? On there, we have now started to install protective devices, because when the squirrels get on top of that transformer, taken into view, okay, and they got a big old fluffy tail, right? All they need to do is relax their tail across the top side of that bushing, and they become a path of ground, right? Transformer attached to the pole. Where's the pole set? Okay, Mother Earth. Squirrels cause more outages on our system 24/7, 365 than anybody realizes. This clamp here that Carl is attached to, they chew through aluminum clamps. Chew through, okay, causing outages on our system. So another demonstration, again, for those that just came in. This can get your attention, okay? You may want to plug up your ears a little. We're going to ground out Sammy. Hot. Top side of the transformer. Oh, not too bad. There's our fuse. Okay. Better example, okay? There's our fuse still attached inside of there.
Oh yeah, this is the best one.
All right, next up, our center device, and that's the trip saver.
They're putting new
Center device here.
breaker in.
Trip savers, do you ever experience this? Come home from work all day, sit down with your family, have dinner, and by that, boom, the lights go out. Could be a blue sky day, okay? Or it's a storm. Lights go out. A few seconds later, the lights come back on, right? A few seconds later, the lights go back out. How many times will it cycle before you lose power? Most of our first responders know it's 3 times. It's this device that's actually operating, okay? This device is operating, center one. It's a trip saver. Tree come down on the line, it trips, sends fault current back, and it trips this device. Automatically resets, and it sends electricity back out the line. It'll sense the fault, it'll come back, trip. Automatically reset. Send electricity out the line, sense the fault, trip. It's gonna do it 3 times. It's how we're trying to restore power to the customer. 60-mile-an-hour wind during a storm, tree comes down, it blows the tree off and initially tripped. Now it blew the tree off, so in one of those cycles, we restore power without doing anything to our customer. Those are on single-phase lines, okay? Single phase. On 3-phase, again, we have what's called a Viper. It does exactly what the Trip Saver does, okay? This one, if it happens, we have to come out, saw Lou there, manually inserting that. We have to fix the problem, we then reinsert it with our hand tools, okay? The Viper, 1 per every 500 customers on our system, all right? We have over 6,000 of these now on the system. So if a tree comes down, let's say we got 5 miles of 3-phase line, and in that 5 miles, we have 4 Vipers. Tree comes down somewhere in the middle. The Vipers actually talk to each other over the wire. And what they do is they isolate the outage to between 2 Vipers. So what was originally 2,000 customers is now 500 customers. 1 per every 500 customers, approximately. So now we only have 500 customers out. In the matter of us snapping our fingers, those Vipers talk to each other and isolate the outage, okay? Reducing our number of customers that are out of power. That device, no matter where it is on our system, Lancaster, Renova, Lakewall, Paulpack, Allentown, no matter where those Vipers are on our system operators down in Allentown today simply have to click a mouse button at their desk to operate the Viper. We do all of our operations today over our wires, and we actually built our own cellular network. It's how we operate devices, and it's how we read meters. Up on a pole, you'll see some, as you're going through the communities, it's a little 1x1 white box that's right below the transformer on the pole, and it's got a little antenna sticking out the bottom. That's our own cellular network, okay? It's how we operate our system. We call it smart grid, okay? We're able to do things on our system without even sending somebody out. So we're gonna demonstrate for you just how the Trip Saver works. No more loud bangs here. Brian's gonna put a tree branch, phase the neutral, dust the dawn light here. There's 1 trip. There's 2 trips. And the 3rd trip, sense the fault, and boom, clear, okay? And the Trip Saver now open. So you saw there a little bit of delay, okay? Probably about the same amount of time you experience at home. Could be a little longer. All depends how many customers, how many amps, all different kind of things that we calibrate that device to do, okay? But it's how we're trying to restore our customers. Now, you'll notice right next to this Trip Saver, this is exactly what it'll look like. Right next to it is what we call a bypass fuse. That is mechanical. You all know that that thing operated, cycled 3 times, and the power went out. Does that give you a green light to go push that tree off the wire? Absolutely not, okay? That wire can become energized at any point. And what's that customer 3 doors up doing? Did they fire up a generator, not open the main breaker, and they're now back feeding the system, okay? Just because they have operated 3 times does not give you the green light to go help someone entrapped in a vehicle. And I know it's tough, right? You're trained. That's what you do to help people in your community. But what we don't want to see you do is become the second victim, okay? Just because they operate. Wait for us, wait for your utility to tell you it's what? Out and grounded. That's when it's safe to do what you folks do to help your folks in the community. Okay, small change over here. Let's talk about the small amount of electricity it takes to actually injure us or kill us. Okay, plain and simple. How many of you are qualified electrical workers during the day? Okay, none of you. How many of you have changed the receptacle in your home? Put them up high. Yeah, none of you are qualified, right? But we've all done receptacle changes, right? Okay. If you did that receptacle change, how many of you did it hot? You didn't want to walk uphill both ways through the broken glass in the snow to get to that panel box. Did it hot? How many of you got buzzed, wrapped, or shocked changing a light up here, right? You're up here trying to change a light out. I can do this while it's hot. If you did and you got shocked changing that receptacle, dining room receptacle, is there much load? You got much plugged in your dining room? You might have a little bulb in the window, okay? If you were changing that dining room receptacle, it's controlled probably by a 15 amp breaker down into your panel box. If you were changing that thing out and you got shocked, you crossed those wires. At that point when you got shocked, you possibly had 15 amps of fault current go through your body when you get shocked to go back and try and trip the breaker down in the panel box. 15 amps. Remember what I asked you in the beginning, amps or volts? Amps, okay? When you got shocked, that 15 went through you. How many, what is, I lost my train of thought. When you got shocked, okay? It only takes 50 to 100 milliamps of electricity. Milliamps, 1/1000th of an amp, to stop our hearts, injure us, or kill us. That day, you possibly had 15 amps go through your body and you lived to tell about it. 50 milliamps of electricity will stop our hearts if the conditions are right, okay? But do you want to take that chance? Okay? 50 milliamps. How do I put 50 milliamps into perspective for us? Okay? You know that I mentioned that little bulb in the window, a night light bulb in your child's bedroom or the bathroom, or a Christmas light bulb. They're a 7.5 watt light bulb. That 7.5 watt light bulb draws 62.5 milliamps of electricity to operate. 50 milliamps is enough to stop our hearts. Okay? You're working around hundreds of amps when you're working near electrical facilities and doing what you do out there, okay? The small amount of electricity it actually takes to stop our hearts and kill us. Take that short walk down to the panel box, open it up, and it says dining room, and you're gonna shut the breaker off. Do you trust the person that scribbled dining room next to that breaker, right? When you walk back up the steps, what do? Hopefully you have that $10 tester, right? And you walk over to that dining room and you stick the two little prongs in the outlet and the light doesn't light. Woo, got the right one, did you? I recommend you take a few short steps over to your kitchen next door and stick that tester in the kitchen receptacle. Why are we doing that? Test the tester, okay? We have them, we test. Ours are thousands of dollars, okay, to be sure we're keeping ourselves safe, to do what we do, okay, test the tester. Could save your life. Household current, can Google this, household current takes more lives every year than these types of facilities do, okay, household current. All right, for all of you, Mylar balloons, we take our kids, grandkids to the local, could be a fireman's carnival, certainly not picking on all of you for what you do, it's education. Mylar balloons have caused more outages on our system the last 2 years than ever before. What's happening today? Gender reveal parties, birthday parties, all kind of stuff. Balloons, right? Do what you do. What do you do when you're done? Let them go, right? We had a set of 6 Mylar balloons 2 years ago between Christmas and New Year's. Somebody let 6 of them go. Guess what? They came down like they all will. When they came down inside of a substation downtown Allentown. When the balloons came down across what we call aluminum bus bar inside of the substation, went across the bus bar and the neutral. Balloon, piece of string, okay, across the neutral. It destroyed that substation. It melted the bus bar. We lost 4,000 customers between Christmas and New Year's from a set of Mylar balloons, okay? If you take your children, grandkids to a carnival, you walk through the gate, the first person they see is a balloon vendor and they want a balloon. We buy them a balloon, okay? What's attached to it? Nylon, Teflon coated string. As a parent or grandparent, where did you attach the string? their wrist, your wrist, or the stroller that we're pushing them in, or we're out having family time. Next time you go, just take a few seconds and look up. All the services, right? We do this presentation, Bloomsburg Fair, every year. Okay, we've been there for the past, I think, 5-6 years. When you go to a carnival, York Fair, right? When you get in there, all the wires feeding all those vendors and food vendors, game vendors, the wire height, ground to the wire inside of there is a lot lower than it is out on our system. So you got 8 10-foot of string with a Mylar balloon attached to the top. And if that Mylar balloon were to come in contact with overhead electrical facilities, will the Mylar balloon conduct electricity? Sure will. Where did that electricity go? Down the string, clear to you, your child, or the stroller that you're pushing them in, causing injury or possibly death from a Mylar balloon, okay? That's what can happen. For us, human contact. All right, power goes out for the entire town you live in, okay? 2 a.m., you get that call to respond to the station. When you come outside of your home, power is out. There happens to be a wire laying across your truck, across your deck, across the driveway. Power is out. Do you have anything in your possession to walk over there, grab that wire off the truck so you can get to the station? Absolutely nothing, okay? Number one, is it out? May not be arcing or doing anything. But again, we stress the importance of generators, okay? Because we see it every storm. And now the solar. Is that line getting backfed from one of your neighbors 3 doors up because they fired up a generator and didn't do what they were supposed to do? If you were to walk over to that wire thinking power's out, when you get right here to this wire to grab it, okay, what's it gonna do? It's gonna jump into your hand. What are we made up of as humans? 65% water, one of the best conductors of electricity. It's gonna jump right into your hand, okay? What's your brain gonna tell your hand to do at this point? Grab a hold. Your brain, electrical impulse, is gonna tell your hand to grab that wire. Are you gonna be able to let go? Are you gonna send enough fault current back to blow that fuse like we did in the beginning? More than likely you're not. And you all know what the outcome will be. You're gonna have an entry and the exit, and the exit is not pretty. The electricity went through you. Hole here, hole there. Everything inside, not to be gross, is cooking. You cook from the inside out. It's just what happens with electricity, okay? Again, the importance of never touching any wire that comes down. This will demonstrate for you human contact. We use a hot dog to simulate your finger. Hot. Touching 7,200 volts of electricity. Notice there, Ron doesn't even have to touch that wire. As you approach, okay, that wire is going to jump right into your hand. Click. All right, what allows us to do the work we do every day? Our rubber gloves, rubber sleeves, overshoes, hard hat, glasses, ear protection, FR clothing. You wear a lot of stuff to keep you safe at a fire scene or an accident scene. We're going to talk about a couple of those here in a second, okay? This is what allows us to do the work we do every day. Rubber gloves and sleeves are tested every 3 months. They're tested to 15,000 volts, and they're tested for a pinhole, because a pinhole in this rubber glove will allow electricity to pass through into me, injuring me, or killing me. That simple. A pinhole, okay? On this, the test date, when they're due, and my employee number. If I pass my gloves to my partner to use, and he is caught with my gloves doing work, we will both be fired on the spot. That is how serious we need to take safety, okay? It's our lives. Leather gloves. Nothing fancy about the leather glove. It's there to do what? Protect the rubber glove. That's it, okay? If you go to a local hardware store, You may have some at the firehouse. On the glove, it says it's stamped, electrically tested, right on the leather glove. Okay? When you go to a local hardware store next time, look, some of them say. Because they say electrically tested, does that allow you to climb a ladder at your home and touch this service wire, climb in a burning building, okay? Clean the gutter at home, paint the eave, just gonna grab this wire and move it out of the way. This leather glove says it's electrically tested. Service wire. 2 energized hot legs, a bare system neutral. Some have 3, depending on how many, what amperage you're looking for. What do you call that coating on that wire? Most of folks will tell us that's insulated. It's insulated wire. Is it insulated as a qualified electrical worker? I give it 0 insulation value. It is not insulated wire. Do not think of it as insulated wire. It's a black coating to protect those 2 hots from the bare system neutral. That's it. You can see, cut this out of the air, how that wire was compromised, right? That coating got taken off of there. What do you think did that? A squirrel, a little buddy Sammy, okay? This running through a tree, why we tell our kids, our children, if this is running through a tree, that is not the tree you want to be climbing in, okay? That coating gets taken off of there. Climb a ladder, electrically tested. I'm just going to grab this wire. All it takes is a pinhole in that coating, and you grab this wire. How high up the ladder are you? 2-story burning building. Cleaning the gutter at home, 2 stories. 18 feet, okay? 20 feet in the air. When you grab this wire, it may not be the electricity that gets you. It's the fall from the ladder that could actually take your life, right? It's going to throw you from the ladder down onto the macadam concrete driveway, crack your head open. So to demonstrate for you, leather gloves, and the fact that they will do nothing for you when it comes to electricity. Again, you'll see Ryan doesn't even have to touch that wire, okay? It'll jump across to you. Per OSHA, okay? What distance must you maintain as a non-qualified electrical worker to 3-phase, 12-5, single-phase, 7200, and this service wire coming in the side of your home? 10 feet. 10. If you know the voltage. They changed it a few years back to say if you don't know the voltage of the line, you now need to maintain 20 feet to that wire. How many companies have the aerial apparatus? Okay? If you have the aerial apparatus and you're trying to get downtown Harrisburg, okay, and you're trying to put a 90-foot aerial ladder up in an alley, how easy is it to maintain 10 feet to all these wires? Okay? It's not easy. So, that aerial apparatus, again, if it's your company or somebody that's responding to help you, that aerial apparatus should never, ever go between phase and neutral. Do not let them. Do not put it there until the electric company shows up and tells you it's what? Out and grounded. Okay? Out and grounded. We had a company paid. It's their job every day. They put it between 3-phase and neutral, energized. They did what they had to do. Those of you that have ever been on one of those and it's 90 feet in the air, what's it do when you're going up and down? It's doing this. The last firefighter got 4 steps from the bottom and it arced over. Luckily, the operator, right, was not doing anything with the levers and knobs, and he was still on the apparatus. But they destroyed a $1.1 million apparatus at the time. This was several years ago, right? What are they today? Probably closer to 2, right? They destroyed it. It blew out every tire, all the hydraulics, all the wiring in that apparatus. And luckily, nobody was killed, okay? Never goes between. Go above right? Go up here, go below the communication. I know it's tough, okay? Until the electric company can get there and make it safe for you. One thing to remember, if that thing is over the wire, okay? If you're over the wire doing what you're doing, okay? And you're done, what are you gonna do? You're gonna pull this thing back across the wire. Make sure the water has stopped flowing out of that nozzle on top of the ladder, up here. Because what happened, okay, they pulled it back across, the water was still flowing, energized three-phase, what happened? Where did the electricity go? Right up to the top, to the actual firefighter that was up there doing what you do on top of that ladder. Shocking the firefighter, okay? Make sure the water has stopped flowing before you pull it back across. Okay, first up for your devices, and that's the fire hose. Will the fire hose conduct electricity? What's in it? Number one, water. Okay, what are you standing in? Water. We call it a drop zone. You got a lot going through your mind when you get to a burning building. Okay, take a few seconds and look, where are the flames in relation to the service wire coming in the side of the home? Where are the flames in relation to the main line? If the flames can get to these wires and burn them free, where do they go? Okay? We had 3 incidents occur. Service wire burned free before we could get there. The wire dropped. Where did it drop and what are the chances? All 3 times it fell directly on the fire hose. Okay? Burn mark in the fire hose. 3 firefighters holding the metal nozzle, flowing water. All 3 were electrocuted. One severe enough, he had to be flown to Lehigh Valley Burn Center. Take a few seconds. Where's the drop zone? If it burns free, where could it fall to? I'm gonna have the guys and ladies run the wire down, or the hose down along the side of the home. I'm gonna run out here along the road and turn and run parallel down and stay out of the drop zone of where that wire could fall. Main line, if that line drops on the apparatus because the flames get to it, where does it drop to? Right on the apparatus. Somebody standing there, operator doing what they do, you could electrocute them. So just take a few seconds and look where the wires are and position yourself. Fire hose. We wet it to show you a wet fire hose and what will happen. Hot. Water, grounded, that piece of fire hose you hold in your hand will conduct electricity. Clear. Ladder safety. Wood, aluminum, fiberglass. Will wood conduct? Absolutely. It's not a great conductor. How about a tree? What's in a tree? Water, sap. Where's it attached to? Mother Earth. Don't think power's out. We're going to help the local utility. We're going to go over there. We're going to push this tree off so we can get Main Street open. County keeps calling you. You got to get the road open. Your response should always be, PPL has not shown up and told us the line is out and grounded. When they do, if they need help from us to get that tree off, we will help them. Okay? Do not think just because the power's out, you should walk over and try to cut that tree off. Do not walk up and put caution tape on the tree. I can't tell you how many times during a storm I get out 2 days after the fact and somebody has caution tape wrapped around the tree that's laying on the primary. Okay? One time that primary was still energized. Somebody was lucky not to be killed. All right? So wood will conduct if the conditions are right. Aluminum. Aluminum, pretty obvious. Most of you have aluminum on your apparatus, I'm sure, right? Maintaining the 10 feet, okay, to all electrical facilities. Ladder extended 30 feet onto the side of a building. Try to pull that ladder off, right? What does it do in the middle? Right? Gives one of these little wiggles, and we think the firefighter, a junior firefighter at the time, thought maybe he lost control, and he was under the understanding the main line was not energized, and laid it back into 12,500 volts, and it was energized. And that junior firefighter lost his life. Okay? Different things you need to be thinking about. Making sure everyone on scene understands what is hot and what is not, what's out. Okay? Fiberglass, the one we're asked about a lot. We use a fiberglass stick to do the work we do every day. That stick is stored properly. We clean it every time when we take it out. And that stick is tested to 15,000 volts. And every time we use that stick, we wear our PPE to keep us safe. If you have a fiberglass ladder, probably more so at home, or maybe the chief says, you know what, we're gonna put a fiberglass ladder on the truck. What are you gonna do? Down to a local hardware store, buy a fiberglass ladder. How are you getting it back? Throw it in the back of your pickup truck, drive it back, hang it on some hooks on the side of the apparatus, hooks in your garage or shed. Take it out, drag it out of your garage or shed, stand it up on your home, paint, running down the ladder. In all those moves, did the fiberglass ladder become gouged, grooved, or dirty? Now it will conduct electricity, okay? You can buy an electrically tested one, okay? They're pretty expensive, but for what you do, if you go to that local hardware store, nowhere on that fiberglass ladder will you find a sticker that says electrically tested, okay? Ours, obviously, when we're down in manholes, okay, doing different types of things, ours are electrically tested. But again, even our sticks, right? We do things to keep ourselves safe, and we're always wearing PPE to keep us safe. So this fiberglass ladder, okay, to show you the fiberglass ladder, gouged, grooved, and dirty, will conduct electricity. Where does that electricity go, right? It wants to go right to ground. Do you run in to help your partner on the ladder? Every step you take to get to your partner on the ladder, you're putting your own life in jeopardy. We'll talk about step and touch potential clearing in a second. Okay, the boot? Yeah, boot first? All right, so the boot you wear, turnout boot, okay? I ask our volunteers, how often do you get new turnout gear? And I usually get a chuckle from the crowd, right? Because our volunteers tell me, if you're lucky, about once every 10 to 12 years, right? 10 to 12 years, you have walked through burning buildings and car debris. Is there a chance in those 10 to 12 years you stepped on something that pierced the bottom of your turnout boot? What's in the arch of your boot? Steel shank, okay? And you think, tired of waiting on First Energy to show up, okay? I got a rubber boot on. I'm just gonna walk over to that wire. We're tired of waiting on the electric company. Gonna walk over there and give that wire a kick. And that wire is energized.